So today we'll briefly talk about linked lists and compare it to another data structure called arrays and see how linked list is much better than arrays in a few areas. So as we know, an array is a collection of data elements of the same type. So if I say this is an array A, it consists of 4 elements and all these 4 elements should be of the same type, be it integer or be it float, anything else. Now when I declare an array, I have to mention the data type, the name of the array and the size of the array. Now this is mandatory in C if I want to declare an array. Note here that before I start the program, I need to know what will be the size of my array. That is, I will need to know how many elements are supposed to be there. Now this can be looked at as a disadvantage because most times right at the beginning I will not know how many elements I want to store, or my collection is going to have how many values. Like example, if I want to take feedback and say that every data element will represent one student, I don't know how many students will give the feedback. So I cannot really say that the size of my array will be 10 students, 20 students or 30 students right at the beginning. Now in this case, we understand that an array size is predefined and array is a static data structure. That is, during execution, I cannot change its size. It will be fixed as it was when it was declared. In this example, this array will only hold 4 elements no matter what is the requirement of the programmer. Then another issue with arrays is, let's say I say that my array size is 4, but I end up storing only one value all the time. All the time I'm using only one value. So the other 3 cells or the other 3 memory area is always wasted because I'm not using it. So I already defined a maximum size saying I'm going to take 100 feedbacks, but it ends up that only 10 students are giving feedback or only 15 students are giving feedback. Then if 10 students are giving feedback, 90 memory space is wasted, which I have reserved while creating the array feedback of size 100, assuming that 100 students will give me feedback. Okay, so these are some of the problems with regards to arrays. Now there are other issues also, like for example, if I want to add any element to the array. Let's say my array has 3 values and I want to add 1 value to the beginning of the array. Now I have to remove all these elements one by one. 7 has to come here, then 6 has to take this place, 5 has to take this place, and then I put the new value here. So insertion and deletion of elements in an array is quite taxing. Also not just taxing, but then you never know that much space is available or not if I want to add that element. So these are some issues. Now linked list is a better option when you compare an array with these issues. Now please note, I'm not saying that we should not use arrays. I'm not saying that it is bad. I'm just saying that when we are going to look at the following issues that we said, depending on the size of the array, insertion and deletion of elements into the array, then a linked list is a better option than an array. Alright, so let's see what is a linked list. A linked list firstly is a dynamic data structure. It's a dynamic data structure. Now what do I mean by dynamic data structure? Dynamic. It can change easily. It can cope to change. That is, if suddenly I realize that okay, my list should have 1 element, then the size of the list is 1. If my list should have 10 elements, the size of the list will become 10. If 1 student gives feedback, right now my list is of size 1. If 100 students give feedback, the size of my list is 100. And all this happens during execution. All this happens dynamically. It's not that beforehand I decide there will be 100 students. I just create an empty list, and depending on how many students give feedback, the list keeps growing or the list keeps expanding in that way. So remember, linked list is a dynamic data structure. Now, a linked list is a linear collection of data elements, but here an array was also a linear collection of data elements because one after the other elements were stored in the array. But what happened is, if the first element was at address 101, then the second element would be an address, let's say 101 plus 2 if it is an integer, which is 103, because integer takes 2 bytes, right? So plus 2, and then 105, because then the next one will be again plus 2, because this integer would take 2 bytes. So like this, the elements would be stored in an array. However, in a linked list, it's not necessary they have to be in contiguous memory location, but obviously every element is linked to another element so that the list is intact and in one place. So now when I say one place, that means I can refer to it by one name and I don't have to go through here and there searching for the different elements using different names. So now a linked list is a collection of nodes. Let me say it's a collection of nodes. I'm just introducing this term node here now. We'll have a look at what is this. This is my linked list. This is my linked list. Looks more like a train with the different bogies that are there. So a linked list is a collection of data elements. Now here, this will hold one data element, this will hold another data element, this will hold another data element. So my linked list here right now is holding 3 data elements. Alright, and then we see when I say data element, it's not as simple as an array earlier. I see there are 2 things here, 2 boxes. What are these 2 boxes? Now, this one entire thing is a node for us. It's a node. Alright, now this node represents the data element, an individual data element, or the information, alright, that is attached to a particular node. So now this node is made up of 2 things, 2 parts. A node is made up of 2 parts. Alright, the first part is the information or the data. Alright, and second part is a pointer or a link. Let me see, a link is a link or it is a pointer to the next node in the list, to the next node in the list. So if there is one more node in the list, then you'll have one more node and this will point to that node. And this will go on depending on how many nodes I have. So you understand now, if one student gives feedback, I will have only this. Another student gives feedback, this is created immediately and added to the list. And this goes on till we want to add nodes into this list or elements into this list. Now if we go back to this first diagram, this is a list of 3 nodes. This is the starting node, alright. Usually we call it the header node, alright, header node. Sometimes some programmers use an external pointer to point to this. It depends on you. So I will say that, okay, I have a list of 3 different nodes, that is 3 elements are going to be stored. This is the header node, and here at the end I see there is this particular arrow going nowhere. It ends in midair. Alright. Now please remember, the last node in a linked list always points to null. Always points to null. So if I have a list and I say the name of the list is RK, alright, this is a list by the name RK. So when I go through this list, I keep going on till I don't reach null. The moment I reach null, I understand that the list is over. I have gone through all the elements of the list. Alright, so here I was saying this is link. We usually call it next. We will call it next for all our other examples that are going to come up. We'll call it next. So now here, this particular node, the name of this node is RK. Alright, and this node, since it's the header node, this node, the name of this node will represent the entire list also. So when I say RK here, RK has 2 parts. One is info, one is next. Alright, so this is info, this is next. So let's say I store some information now to make it look more real. So I have 3 pieces of information there, 5, 6 and 7. So when I say 5, alright, 5 is the information attached to this node, and this pointer points to another node that has the information called 6, and this node has a pointer to another node that has information called 7, and this node points to null. That means this is the last node. There's no other node after this. Alright, so that is some basics of your linked list. Alright, so please remember, linked list is nothing but a collection of nodes, and node is nothing but representing a data element or the info. So that is one thing. Now, there are different types of list that we will be dealing with. Right at the beginning, when I have no list, no student has given me feedback, and I only want to create a list, but no node has been created as yet. So this points to null, because there's no node created as yet. This is an empty list. Empty list. When there is no actual list, alright, that is when there are no nodes, okay, no nodes. So the list is just a pointer right now, trying to point to any node that will be created. So this is an empty list. Then we have another type of list which is called a singly linked list. Singly linked list. Singly linked list is what we just saw in our previous discussion just some time back. Singly linked list. Alright. Then in singly linked list, what happens? Each node is linked to its next node. That is, it saves the address of the next node. Then we have a doubly linked list. Doubly. From singly we come to doubly. That means there will be double pointers. Doubly linked list. Here each node holds 2 pointers. Alright. So I'll have one more pointer attached. Let me just do this. Okay, one more pointer attached. So this will be the value. Alright, this is the pointer pointing to the next node, and there will be another pointer that will point to the previous node. So this will point to previous, this will point to previous. Okay, obviously this will point to null since there is nothing previously. Alright, so that is a doubly linked list. Then we have a circular linked list. A circular linked list, Now, a circular linked list, what happens here, let's say this is the list that I've created, is actually a singly linked list only, with the extension that the last node does not point to null, but it points to the first node. So it's circular. That means from the first node I have the link to all nodes, and even from the last node I have a point back to the first node, which leads me to all other nodes. Alright, so that's a circular linked list. Now circular linked list may be for a singly linked list, may also be there for a doubly linked list. So if it's for a doubly linked list, alright, so this one will point here. Okay, so we'll have a look at each one of them. For now, just trying to understand what are the different types of linked lists. So that was just some basic. In the next video, we will have a look at how to work with these linked lists that we've just discussed, how to create a node and how to start attaching these nodes one after the other so that it forms a list.